word problem, either on your page if you have it or in a space that's available. The hardest part in a word problem is being able to draw a diagram correctly. If you can draw the diagram correctly, then using mathematics afterwards is no problem. So I want you to read this question and see if you can draw the picture, right? And if English isn't your first language, it makes it even harder to see if you can draw. So see if you can figure out some new words. Take out your phone if there's words that you don't understand. Translate them. If you are artistic, draw it. Extra artistic features would be great. If you are not artistic, pretend that you're artistic to the best of your ability. It's fun to pretend. Okay, how did you do? So we have, first of all, a retaining wall is a wall that usually holds up dirt or something to make it so that it doesn't fall down. So I'm going to draw my retaining wall, and it's already bent a little bit. So here is, as close as I have to the brown pen, I got grass up here. All right, so there is our retaining wall, and we are told that it is at an angle of 70 degrees to the horizontal. Things are not looking good with this retaining wall. It looks like, well, it even has a few cracks in it already. Look at, and this is where I'm pretending to be an artist. Things are going well. I'm thinking tomorrow I'm going to quit teaching math and just go down to the art room. Anybody in art this semester? Take it next semester. I'll probably teach. Look at that. That's amazing. Then a support made out of some orange stick. There we go. Really did well here. My engineering. I'm like, yes. There's a big concrete wall about to fall over with a lot of dirt behind it. I'm just going to put a little wooden stick and stick it up and say it's all good. That stick is placed 5 meters from the base, so I know that this is 5 meters. 2.5 meters from the base, so that would mean that this length will be attached to the wall. Oh, I even attached it with a blue screw. There we go. Look at that. Did really well. Because that's what you can do. You can just screw a blue screw through wood into concrete, no problem. Didn't really attach it to the ground. Maybe some two-sided Scotch tape here. That'll be really good. And there we go. So now this is the situation that we have. Determine the angle between. Determine the length of the support to the nearest tenth of the meter. So I'm going to put an X here. That's the first question they're asking. Determine the length of the support. So the hard part here is drawing the picture. Once you've drawn the picture, notice it's not a right angle triangle. If I want to find X, I can't use SOHCAHTOA or a squared plus b squared equals c squared because it's not right. Next, I look if I can use the sine law. In order to use the sine law, I would need an angle and its opposite side. Even though I have the 70 and I want to find x, I don't know both of those. You need to know an angle and opposite side actual numbers in order to use the sine law. Can't use the sine law, we need to use the cosine law. So to use the cosine law here, those two to go together, I am going to use the equation that is an x squared equals, it has a cos of, and so this is where the 70 degrees would go, that goes with the x squared. The rest of the stuff in the formula doesn't matter, the order, so I can go 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos 7. So again, your formula looked like this. C squared equals a squared plus b squared minus 2ab cos c. And this would be another one. You should try to prove the cosine formula. There. Plugging things in. Now I'm going to go to my calculator. I'm going to type all of this in. So 2.5 squared plus 5 squared minus 2 times 2.5 times 5. I'm going to do mental math and put that all in my head and get 25. Because 2 times 2.5 is 5. 5 times 5, 25. Cos of 7. 22.69. I can now square root that. So x squared was 22.7, and x is equal to 4.76 to the nearest 10. 4.76 amounts to 4.8. Units are meters. So we've now solved for x. X is 4.8 meters. Second part of this question. Find the measure of the angle. So I'm going to put in blue a theta here. It wants to find the measure of the angle between the support and the wall. Ooh, is that between the support and the wall? Let's put my angle there. That would be, the support is the orange thing. The wall, which so artistically drawn there is easy to tell, is the one with the cracks in it. That's the angle they want to find. So now we ask ourselves, can I use the sine law? Can't use SOHCAHTOA. It's not a 90 degree. Do I now know an angle and its opposite side? Yes. I know angle and opposite side. With the sine law, can you look already and tell me if it's going to have one answer or two answers? If you can't, we'll find out. But there is a shortcut to find out if there's only going to be one answer or two answers, thinking about the triangles that we drew at the beginning. So, I'm going to use the sine law. I want to find theta, so in writing the sine law, that's what I would put first. Sine theta. What's opposite of theta is the 5. Which are the two that I know? I know the 70 and the 4.8. And so sine of theta will equal, multiply both sides by 5. And technically, while you're doing this, you shouldn't use 4.8 because it's rounded. You should use the 4.7646439885. You should use all those decimal places. So when I go to type this in, I'm going to go 5 sine 70 divided by, oops, close my bracket, divided by, and instead of using the 4.8, I'm going to, on my calculator, steal all of those values. Either doing answer from before or using all of those decimals. Pushing enter tells me 0.986. So I now know 0.986 is sine. What do I have to do? I have to think about my CAST rule. Is the sine theta positive or negative? It's positive. Sine is positive in 1 and 2. It is not in quadrants 3 and 4. I would have to think about drawing an angle in quadrant 1, drawing an angle in quadrant 2, thinking about my reference angles, so I could find my reference angle by doing sine inverse of positive, which it already is positive, 0.96. Again, I use all of the decimal places, and I get a reference angle of 80.5. Does it say to the nearest tenth for the angle too? Oh, it says to the nearest. So to the nearest degree, the reference angle would be 80 degrees. Can you see in quadrant 1? Theta would be 80 degrees. Can you see in quadrant 2? Theta would be 100 degrees. Let's go to our picture, see if they both make sense. 80 degrees. Or 100 degrees. Do they both make sense? Yeah. Now the answer in the textbook only says the 80, so did we do something wrong? Or did the textbook just forget the 100 degrees? Okay. Questions for practice on this one are just number 6. I'm going to think about oh, yeah. Okay, I didn't think about this one some more. But we'll end the video here. We'll think about that some more.